Hello, good morning, students. In this lesson, we are going to look at weathering as a complementary process. What this subtopic is meaning is that the various types of weathering processes, that is the chemical weathering processes, the physical weathering process, and the biological weathering processes, tend to complement the work of each other. In other words, chemical weathering processes tend to ease the occurrence of physical weathering processes. Then at the same time, the physical weathering processes can make chemical weathering activities to operate easily and much faster. Then also biological weathering processes can easily activate the occurrence of either physical or chemical weathering processes. So in this case, you realize that the weathering processes tend to complement the work of each other in order to achieve complete weathering processes. So in this case, the physical, chemical, or biological weathering processes do not occur independently, but they help each other to achieve complete disintegration of the parent rocks. Now, how do we know that the various weathering processes complement the work of each other? In the first place, when we look at, for example, the chemical weathering processes, this is a form of weathering process which weakens up the rocks. Then the moment the rocks are weakened up chemically by the chemical weathering processes, then it becomes very easy for physical weathering processes to destroy these rocks which have already been weakened. For example, a rock that had been weakened chemically can be broken easily by a trampling animal that steps on it. For example, animals like cows, animals like goats can step on the rock and easily break the rock. A rock that has been chemically weakened can easily be destroyed by maybe a farmer who, in the process of cultivating, may land the hose on the rock and eventually breaking up this rock easily. So as you can see here, therefore, that chemical weathering processes tend to make the work of physical weathering processes easy, and therefore they are complementary in operation. Then secondly, we look at the roles played by the roots of the trees. That is biological weathering process. So when the roots of the trees penetrate through rock cracks and joints, these rock cracks and joints ends up being widened. So the cracks becomes larger and bigger. And this will promote the occurrence of chemical weathering processes, because the agents of chemical weathering, for example, water and air, can easily percolate along these widened joints and the cracks. And this will bring about deep chemical weathering within the rocks which has been affected by the effect of biological weathering, or the physical activities brought about by biological weathering processes. So in this case, you can see that the biological weathering process makes the occurrence of the chemical weathering processes very easy, because it promotes deep rock rotting. Another form of weathering, another form of physical weathering, which makes the occurrence of chemical weathering easy, is what we call the spheroidal weathering. If you can remember, there are certain types of rocks. If they absorb water, they expand or swell, and this may bring some chemical changes within the rock. Now, when a rock of that nature is affected, it begins to peel off in thin layers. That process by which the rock surfaces peel off in thin layers after absorbing water is what we call the spheroidal weathering. So this therefore means that when the rock layers at the surface peels off, the underlying rock surfaces will be exposed at the surface to the elements, to the agents of weathering, for example, water and gases. And this therefore means that the layers of the rocks that would not have been easily accessed by the agents of weathering will now be exposed at the surface because of the peeling of the outer layer of the rock by spheroidal weathering. And this will bring about deep chemical weathering within the rocks which have been affected by spheroidal weathering. Another form of weathering which complements the work of chemical weathering is what we call block disintegration. If you can remember, this is a weathering process in which a parent rock is broken down in large rectangular shaped sizes. And this mainly occurs in rocks which are well jointed and is caused by alternate heating and cooling of the rocks along the joints. Now, when the rocks break down through block disintegration, it means the cracks and joints within this rock becomes widened up and therefore breaking the rock into large rectangular shapes. Now, as you can see here that the rock joints have already been widened by physical weathering processes. Now, after this, other agents of weathering, for example, water and air, can easily circulate, pass or run along these widened joints and cracks. And this will bring much deeper chemical weathering to take place within the rocks which have been affected by block disintegration. And this will promote deep rock rotting within the parent rock masses. Number 4, we have the effect of exfoliation weathering caused by alternate heating and cooling. Exfoliation weathering is a physical weathering process which greatly promotes the occurrence of chemical weathering processes. In which way? Now, when the outer layer of the rocks peel off in the process of exfoliation weathering, it means that the underlying rock layers will be exposed at the surface to the agents of chemical weathering, for example, water and air. And this means that the underlying layers of the rocks can easily be weathered by chemical means. And remember, this would not have been easy if the outer layers of the rocks have not peeled off to expose the underlying layers of the rocks. So in other words, the agents of the chemical weathering wouldn't have reached deep into the rock to cause deep chemical weathering and deep rock rotting. So as you can therefore see that here, the exfoliation weathering aids the occurrence or promotes rapid occurrence of chemical weathering processes and deep rock rotting of the rocks which have been affected by both physical and chemical weathering. Number 6, we look at the role of pressure release. Pressure release is a physical weathering process which occurs when the overlying rock debris or broken weathered rocks are removed away by running water. In the process of erosion, they are removed away by running water and wind. So this means that the underlying layers of the rocks which are covered under the ground, will gradually be relieved of the pressure caused upon it by the accumulation of these thick layers of the weathered rock debris. So as these rocks are removed rapidly by the process of erosion, the underlying rocks will begin to expand upwards. So as they rise or expand outwards because of the pressure release, then they will develop some curved joints or cracks parallel to the surfaces of the rock. And eventually, you will find the cracks that will have developed through the pressure release will promote easy penetration of agents or weathering, for example, water and air deep into the rock along these cracks and the joints. And this will promote eventually deep chemical weathering and deep rock rotting. And also, this pressure release will also aid the work of chemical weathering, deep chemical weathering, in the sense that when the rocks swell up and they develop the curved joints parallel to the rock surfaces, then with the time they slide off, they fall off. Meaning, therefore, the underlying rock layers will be exposed at the surface. And this will eventually be accessed easily by air and water, which are very good agents of chemical weathering. And this will promote very deep chemical weathering and deep rock rotting. So in this case, you will realize that pressure release, which is one form of physical weathering process, will promote the occurrence of other chemical weathering processes by exposing the underlying rock surfaces at the surface. Then another way in which weathering processes are complementary here is that, for example, we have physical weathering process which brings about breakdown of the rocks into smaller and smaller fragments. Now, the moment the rocks are broken down into smaller and smaller fragments, gradually water and air can penetrate into these already fractured rock fragments easily. So, in other words, these rock fragments can deeply be attacked by the water and air that are very good agents of chemical weathering, and this will promote very deep chemical weathering processes taking place within the rock. So the rock fragments can easily fracture. The rock fragments which have been broken down by means of physical weathering can easily be broken down by the process of hydration, the process of oxidation, and the process of carbonation, which are chemical weathering processes. Then we look at the role of burrowing animal. This is a form of biological weathering which can be promoted by animals. So these animals dig tunnels under the ground physically, and this therefore promotes physical weathering, a form of biological weathering process which brings about the physical destruction of the rocks. Then later, water and air can circulate along the tunnels which have been produced by these burrowing animals deep under the ground, and this will promote deep chemical weathering and deep rock rotting. Number 9, chemical weathering processes, for example, oxidation, carbonation, and hydration, may decompose rocks by chemical processes. So the rocks can easily be weakened up by these various chemical weathering processes. Now, the moment a rock is destroyed, weakened and decomposed by chemical weathering processes, Then other forms of physical weathering, for example, trampling animals, can land on this weakened rock, and the rock can easily fracture that down into smaller and smaller fragments. So in this case, you can see that chemical weathering processes complement or aid the occurrence of physical weathering in order to bring about complete destruction of the parent rocks. Another way in which weathering processes are complementary is when you look at the role of man. Man can promote weathering, physical weathering or biological weathering, by means of mining or rock quarry. By means of mining, for example, the underlying rocks, the overlying rock layers are removed away, especially in the process of open cast mining method. This means, therefore, the underlying rocks which are deep under the ground are exposed outwards to the agents of chemical weathering, for example, water and gases. And this means that the underlying rocks which have been so deep under the ground, which would not have otherwise been accessed by water and air, can now easily be exposed at the surface. And this will promote deep chemical weathering taking place within the rocks deep under the ground. And this will promote deep rock rotting. So from all these examples, as you can see, therefore, that there is no weathering process that occurs independently. The three different weathering processes tend to work together with each other, and therefore they complement the work of each other in order to bring complete breakdown of the rocks into smaller and smaller fragments. So, dear students, I want to thank you very much for opening to this program. Open and listen to it, and then also try to read the notes from the platform so that you may be able to understand how the weathering processes are complementary to each other. Otherwise, I thank you very much once again, and I wish you a very beautiful lesson and a beautiful day. Take good care of yourselves, please. Thank you very much.